In this lesson, we will first master limiting reactants, theoretical yield, and percent yield for the formation of calcium hydroxide. Then, we will practice a real-world statistics test of a proportion. Let's begin with the chemistry part. The balanced precipitation reaction is calcium chloride plus 2 potassium hydroxide yields calcium hydroxide plus 2 potassium chloride. Suppose in your experiment you measured masses similar to these. We will illustrate with 0.62 grams of calcium chloride and 0.80 grams of potassium hydroxide. You can replace these with your own lab values and follow the same steps. Step 1. Convert grams to moles using molar masses. The molar masses are about 110.98 grams per mole for calcium chloride and 56.11 grams per mole for potassium hydroxide. Now compute moles for each reactant. Step 2. Determine the limiting reactant from the stoichiometric ratios. The reaction needs 2 moles of potassium hydroxide per 1 mole of calcium chloride. If all calcium chloride reacted, it would need 2 times its moles of potassium hydroxide. Compare the potassium hydroxide needed with what you actually have. The smaller side limits the reaction. Step 3. Compute the theoretical yield of calcium hydroxide. From the balanced reaction, 1 mole of calcium chloride makes 1 mole of calcium hydroxide. So the moles of product equal the moles of the limiting reactant. Convert moles to grams with its molar mass, 74.10 grams per mole. Step 4. Measure your actual yield after filtering and drying the solid. Write it down as actual. Percent yield equals actual divided by theoretical times 100%. We'll illustrate with an example actual yield of 0.35 grams. 2 common reasons why actual yield is lower than theoretical. 1. Incomplete precipitation or some product remains dissolved. 2. Product lost during transfers or stuck to glassware or filter. When the limiting reactant is used up, the reaction stops. Any excess of the other reactant remains unreacted in solution. Now, repeat the stoichiometry for 1.66 grams of calcium chloride and 1.22 grams of potassium hydroxide. First, compute moles. Next, check the limiting reactant. Finally, compute the new theoretical yield of calcium hydroxide. Next, let's test a claim about a proportion using a normal approximation z-test. A drive-through study observed 333 orders, with 40 inaccurate. We will test at alpha equals 0.05 the claim that the inaccuracy rate equals 10%. First, write the hypotheses. Compute the sample proportion, the standard error under the null, and the z-statistic. Because this is a two-tailed test, the p-value is 2 times the upper tail area beyond the absolute z-value. Let's visualize the standard normal curve and shade both tails beyond the observed z. Make the decision at alpha equals 0.05. Since the p-value is larger than 0.05, we fail to reject the null hypothesis. It is plausible that the inaccuracy rate is 10%. That level may still be too high for a business goal, so the restaurant should work to lower it. Summary. In stoichiometry, identify the limiting reactant from mole ratios, compute theoretical yield, then percent yield using your measured mass. In a 1 proportion z-test, write hypotheses, compute z and p-value, and compare with alpha to decide.